Hello, everybody. I am redoing the video because it wasn't a good one. So here we go. We're doing 71, 89, 92, and 103 in this video. That's what you guys voted on. Let's do number 71. Kind of a little bit of a nuisance on this one, but the question asks us to find an equation of the tangent line, so we need y prime of pi over 4. And we also need a point, and they gave us a point, which was very nice of them. Root 3 over 2. Okay, let's do the derivative. We need f prime. Oh, I'm also going to let y equal f of x. Just because I didn't have a y before, and I should probably put one in there, since I used it over here on the right side. So let y equal f of x, and let's do f prime. But I see something that I can do here. I want to go and take that half down in front. I want to take this square root and make that a half. So I can write f of x as 1/2 ln of 1 plus sine squared x. Okay, that's number one. Number two, let's do the derivative. I get f prime of x is equal to 1 over this 2 stays down here. This argument goes down here. And the derivative of this, because I need the chain rule, the derivative of that guy is, let's do some side work over here, d dx of 1 plus sine of x, and then that sine x is squared. Phone's buzzing. Okay, 1 plus sine of x, and that's squared. Okay, derivative of 1 is 0. The derivative of this sine squared x is going to be 2 sine x, and then the derivative of sine x is cosine x, because you need a chain rule for that part. So we have in the numerator times 2 sine x cosine x, and the 2's cancel. So now you're left with, and actually, let's just keep going and plug in our slope of pi over 4, or our value of pi over 4 to find the slope. So we got f prime of pi over 4. Let's pick a different color. Equals sine of pi over 4 times cosine of pi over 4 times 1 plus sine of pi over 4 quantity squared. Well, sine of pi over 4 is 1 over root 2, or root 2 over 2. 1 over root 2 again, squared. Okay, 1 over root 2 times 1 over root 2 is 1 over 2, so we get 1 over 2 on top. And then we are dividing it by 1 plus 1 over root 2 squared is 1 over 2 again. And let's go and just do some more math here. We have 1/2 plus, this is 2 over 2. So that's going to be 3/2. Two ways you could do it here to finish up. You can do 1/2 divided by 3/2, which is the same thing as multiplying by the reciprocal. Doing that leads you to 1/3. Or more simply, you could just take, because we have the same denominators, you could take those out and be left with the remainder, which is 1 over 3. Bottom line, our slope is 1 over 3. So we get equals 1 over 3. And that means we can write our equation of the tangent line. Our equation of the tangent line is going to be y equals 1 over 3, parentheses, x minus pi over 4, plus ln of root 3 over 2. And the root is over everything. All right, that's A. For B, not really big on this one, but let's just do it anyway. For B, here's the graph. I entered y1 as f of x, y2 as our tangent line, and that's what it says to do. Use the graph utility, graph the function as a tangent line at the point. And I zoomed in on this point, and this graph looks about tangent. The point that you're interested in is going to be right here, which is right here. And at this point, the red line does look tangent to the blue curve. So it looks good there. It says use the tangent feature of a graphic utility to confirm your results. So let's do that. We got second and calc. And let's do 6, because that's the derivative one. And let's type in pi over 4. So second pi divided by 4 equals, and right here tells you that this is going to be 0.33333 which is 1/3. So we're good. That's 71, guys. Let's go on to the next one, which is 89. All right, 89. Let's take we need a relative extrema, then we need points of inflection. So let's do relative extrema first. That means we need our first derivative. Y prime equals, let's do first times second prime plus second times first prime. And we'll say f is first, ln of x is second. So we have x times derivative ln of x is 1 over x, plus the second is ln of x, times the derivative of the first, which is 1. Okay, simplifying that, we get 1 plus ln of x. Now we can go and set the first derivative equal to 0. And the first derivative set equal to 0 is going to be 0 equals 1 plus ln of x. And we're going to move the negative 1 over equal ln of x, and we're going to exponentiate. And we're going to get x equals e to the negative 1. I also want to point out that the domain of this function, the domain, is going to be all positive numbers. The reason I know it's all positive numbers is because natural log's domain is positive always. So we have x equals e to the negative first. That means there can be no other critical numbers. Now what? Now we have to do a line test and see what's going on for e to the negative 1. So we got e to the negative 1. This is y prime. And let's look at the left side. The left side. So I could plug in a number like e to the negative 2. And that would be 1 plus natural log of e to the negative 2, which is going to be 1 minus 2 times 1, because the exponent drops in front. And natural log of e is 1, and I get a negative value. You can repeat that process, like for e to the 0 over here. You get 1 plus natural log of e to the 0, which is, I mean, it doesn't matter how you do it, but this value is 0, which means this value is 1. A positive 1, by the way, which is a positive. Oh, look, y prime changes signs from negative to positive. Yay! And that means that we have a min, or local min. Okay, local min at e to the negative 1. To find the actual relative extrema, we will need to plug it in. So let's go and do y of, I'm going to erase this domain part. So to find the actual extrema, let's plug in the point, and we'll do y of e to the negative first, which is going to be 1 over e, because e to the negative first is 1 over e, times ln of 1 over e, or e to the negative first, which is going to be negative 1 over e. If you're not sure about that, please resort to your pre-calculus videos. Okay, so final answer, 1 over e, comma, negative 1 over e. Yay! Okay, that's just the extrema. I noted again that because of this ln of x, our domain is always positive numbers. That's going to come into effect when we look at points of inflection. So let's take y equals x ln x. Okay, so y double prime. Well, if y double prime is the first derivative, or is the second derivative of the first derivative, and we had y prime equals x plus 1 plus ln x. So the second derivative is going to be equal to derivative of 1 is 0, derivative ln of x is 1 over x. And if we're looking for any critical values here, we can find out that x can equal 0, but oh my gosh, x cannot equal 0 because that's outside of our domain, which means no points of inflection. Hooray, our work is done. Yay. Okay, and you can use the graphing utility to check your result, and you can do that on your own. Next. 92. Oh, 92. You great, horrible problem. Okay, same problem of the extrema. So y prime is equal to, let's do first times second prime plus second times first prime. Okay. First, x squared times 1 over x over 4 times derivative of x over 4, which is just 1/4. If you're not sure about that, please make sure you ask, plus ln of x over 4 times f prime, which is 2x. I'm just going to show you anyway. I don't, you're watching this for a reason. d dx of x over 4 is equal to the same thing as d dx of 1/4 x, which is 1/4. It's the slope of a line. Okay, so that's equal to x squared times 4 over x times 1 over 4. It's 4 over x because it's the reciprocal. 1 over x over 4 is the reciprocal of x over 4, so 4 over x plus ln x over 4 times 2x. Let's see, let's go and do 4 here. Let's cancel those guys out. And now we end up getting x plus, and then the next part kind of stays, ln 2x, ln of x over 4. Okay. I'm going to also simplify something here. I'm going to factor, not simplify, I'm going to factor an x out of each term just so I can plug numbers in easily. So that's what I get for y prime. And if I set y prime equals 0, this is just a long problem, then because of this x, I get x equals 0, so that's 1 root. Then I have to set y plus 2 ln x over 4 equal to 0. So let's go do that fun part. Let's see, 1 plus 2 ln of x over 4. 0. I'm going to not show all the steps, but I'm subtracting 1 divided by 2 to get negative 1/2. I exponentiate both sides to get x over 4 equals e to the negative 1/2. And I get x is equal to 4e to the negative 1/2. Fun stuff. Okay, so we got two critical points. We got x equals 0 and x equals 4 to the e to the negative 1/2. So let's do a line test. So we got 0 and 4e to the negative 1/2. Now I want to be careful here because is 0 even in the domain? No, it's not, Mr. Lakin. 0 is not in the domain. Bye-bye. Okay, so now we can just have to do one value here. Let's see here. So I'm not really sure what 4e to the negative 1/2 is. So when I'm in a case like this, I just go with like a huge number, like 100, because I want to know the sign. Okay, 100. And if I plug in 100 here, I get 100 times 1 plus 2 times ln of 100 over 4, which is 2 ln of 25, which is going to be a positive number no matter how you do it. So it's going to be 100 times 1 plus a positive number, which is going to be a positive value. Now, for 0, I can plug in a number that's less than this, like e to the negative 1/2. So let's plug in e to the negative 1/2 and see what happens here. So we have e to the negative 1/2 times 1 plus 2. And the reason I picked e to the negative 1/2 is that's certainly smaller than 4e to the negative 1/2. Okay, so 1 plus 2 ln of e, 1/4 e to the negative 1/2. Okay, that's kind of confusing. I'll try to do that. Let's see what the sign is here. So we have e to the negative 1/2 times 1 plus 2 ln of 1/4 minus 1/2 of times 2 times ln of e. So I used some properties here. I broke up the 1/4 e to the negative 1/2 to kind of see what was going on here. And I got minus, the 1/2 came down in front, and then it's natural log of e, so those all cancel, and I just get minus 1. And that cancels, 1 minus 1 is 0. So now I'm just left with e to the negative 1/2 times 2 ln of 1/4, or for the negative first. And that means that that's going to be, if I do another property here, I get e to the negative 1/2 times negative 2 ln of 4, which is a negative number. That was a difficult one. Ms. Schwartz might have had a better way. That's just the way that I thought of it on the fly. So that means y prime changed from negative to positive, which means I have a local min. And hold on, I need to check something, because I might have said the wrong thing on the other one. Did I say local max or min? Oh, no, I did. I said local min. Good. Okay. So local min here. So, great. Now we have to plug in 4e to the negative 1/2. Awesome. I've never been happier in my life. So let's go and plug in 4e to the negative 1/2 into y to see what the extrema is. We're going to get 4e to the negative 1/2 squared times ln of 4e to the negative 1/2 over 4. You can do this without a calculator. That's going to be 16e to the negative 1 times the 4's cancel, and the negative half comes down up front, so times negative 1/2, which is going to be negative 8 over e. Oh my gosh, this is horrible. Okay, so that means our local min is going to be 4e to the negative 1/2, comma, negative 8 over e. How much time you want to spend on actually trying to understand this and do this, up to you. Chances of it being on an AP test are relatively slim because that's kind of a lot of more pre-calculus logarithm problems instead of you actually, if you know the stuff. All right, next I'm going to take this part. I'm going to do the second derivative on this part. So let's do it. Yeah, let's do it. Woo, I'm so excited. Okay. Okay, so y prime was equal to x plus 1. Hold on, mess that up. Okay, and then I'm almost done here. 2 ln of x over 4. Okay, y double prime. Okay, 1. X is 1 here, so it's going to be 1 plus 2 ln of x over 4. Okay, plus x times, so I'll put the 1 here just to show that I took the derivative, plus x times, let's take the derivative of the inside, and we get 2. Okay, so 2 times the derivative of ln of x over 4 is going to be 1 over x over 4 times 1/4 for the same reasons I listed above. And let's simplify this. Okay, these are horrible problems. Who assigned these problems? Me? Did I assign these? That's mean. Okay, so I get 2. 1 plus 2 ln of x over 4. Sorry, I changed colors there. Plus 2. Because you saw that these fourths cancel and the x cancel, so you're just left with the 2. I could actually factor 2 out of this, just because I can. So you get 1 plus 2 ln of x over 4, plus that second one, which is going to be, I can combine these two ones to get 2 plus 2 ln of x over 4. Wow, this is just a factoring party. Because now I can factor that again and get 4, take another 2 out of each one, right? Multiply those 2's on the outside and get 4, 1 plus ln of x over 4. Wow. Okay, let's go and do a second derivative test. Y double prime equals 0, which means that I need to set 1 plus ln of x over 4 equal to 0. By the way, you could have jumped right to y prime equals 0 at this step if you wanted to. You did not have to do all that extra work. Okay, so now let's go and get our answer here. So let's go and move the 1 over and exponentiate. So we get ln of x over 4 equal to e to the negative 1. E, because I subtracted the 1 over and exponentiated, so I get x over 4 equals e to the negative 1. X is equal to 4 e to the negative 1, or x is equal to 4 over e. Okay, that's supposed to be my point of inflection. I don't have any other points here, so let's go back to the, let's do a line test and make sure that that's right. Oh gosh, this problem will end at some point. 4 over e, y prime, double prime. Okay. So I'm looking at this equation, seeing what happens when I have a really, really big number and a really, really small number. If I pick something like 100, I'm going to get a positive number here and plus a positive number, plus a positive number. That's going to be positive. If I pick a small number like 1 over e, 1 over e is pretty small. If I pick 1 over e, I get 4 times 1 plus ln of 1/4 times 1 over e, which is going to be 4 times 1 plus ln of 1/4 plus ln of e to the negative 1. But we can see here that ln of e to the negative 1 is negative 1. So I'll finish this up here. 1 plus, this is going to be negative 4. ln of 1/4 is going to be well, we'll just keep it as ln of 1/4. ln of 4 to the negative 1, let's call it. And then the negative 1 here comes down in front. ln of e is 1, so minus 1. Those cancel. This negative 1 comes down. We have 4 times negative 1 times ln of 4, which makes this a negative value. Okay. I really don't think there was an easier way to do the problem. If I was wrong, please, please, please correct me. So that means that for 92, let's get your point of inflection then. We definitely have a point of inflection because the sign changes on the second derivative. The function is continuous there, so we're good there. So let's go and plug in that point, which is 4 over e to there to get the coordinate. 4 over e squared times ln of 4 over e times 1/4. I think that's it, right? Yeah, that's right. Okay, I'm going to have to go soon, so we better hurry this up. ln of that. Okay, we got 16 over e squared times ln of e to the negative 1 is going to be negative 1, which is negative 16 over e squared. So the point of inflection is going to be 4 over e and negative 16 over e squared. And that is a problem that I would not waste any time trying to have to glean something out of. Last one, 103. Okay, I'm going to assume that you can graph this. Okay, so you graph that on your own. For B, use the model to approximate for which the monthly payment is 1398.43. So I'm not going to solve this for you, but I'm going to tell you what to do on your calculator. So to approximate the term of a home mortgage, you're going to need to solve for T as in years. So you're trying to solve for T, and X should be the monthly payments. So you're literally plugging in X equals 1398.43. So again, I'm not going to do this problem for you, but do T of 1398.43. Okay, for C, use the model to approximate the term. What is the total amount paid? Okay, so it looks like it's again the same thing. The term. So again, you're letting X equal 16, 11, 11.19. I'm not entirely sure why you guys asked me for this one. And then for D, to find the instantaneous rates of change, now you're going to need, and again, this will be with a calculator, T prime of 1398.43 and T prime of 1611.19. I'm going to get some of these answers for you here because I'm not entirely sure why you asked these. So let's do this. I have it here. Okay, T of X is bigger than 12. This times won't be able to see it because we need to adjust our range. Let's 0 to, let's do, there it is. So T of the first one, 3, means that our mortgage, our term was 30 years. For the second one, T of 1611.19, that means our term was 20 years. So the more you pay in, the less time you have to pay it over, less interest you pay. For D, T prime of 1398.43 is okay. So that means that the rate is decreasing. Do you have to interpret it? No, never mind. Okay, so ignore what I just said. And then we also had T prime of 1611.119. Okay, so those are your two rates. And then finally for E, write a short paragraph describing the benefit of the higher monthly payment. I mean, I hope you guys can see here that your term drastically reduces if you end up paying just a little bit more toward the That's it, guys. Thanks for watching the video. I hope these helped